How do graph databases model evolving relationships? Imagine trying to keep track of a busy social network where friendships form, change, or fade away over time. That's where graph databases really shine. They are built to handle data where relationships are just as important as the data itself. Unlike traditional databases that use tables and foreign keys, graph databases use nodes, edges, and properties to store information. Nodes are like the people or things in your network. Edges are the connections between them, like friend of or works with. Properties are details attached to nodes or edges, such as when a friendship started or ended. When relationships change over time, graph databases have clever ways to keep track. They can store multiple edges between the same nodes, each with different properties. For example, if someone worked at a company for several years, each job period can be a separate edge with start and end dates. Adding timestamps or time ranges as properties on edges helps track when a relationship was active. This makes it easy to ask questions like, "Who was my friend last year?" or "Which relationships are still current?" Because graph databases are schema flexible, creating or removing relationships is simple. You don't need to change the entire structure, just add or delete edges as needed. Different types of edges can representing various relationship kinds like colleague, family, or partner. Each can evolve independently, making the model adaptable. Some graph databases support pattern matching queries that can spot changes over time, like new connections or relationships that have ended. In real-world applications, this flexibility is very useful. Social media platforms use it to model friendships and followers that change constantly. Recommendation systems track how user preferences shift over time. Fraud detection tools monitor transaction patterns that evolve, catching suspicious activity. Content management systems use graph databases to manage different versions of documents and how they relate to each other. For backend developers, graph databases make it easier to work with complex, changing relationships. They allow direct representation of connections and quick updates. APIs built on these databases can easily query or modify relationships with a temporal context, making server-side logic more straightforward. So, in essence, graph databases model evolving relationships by using flexible nodes and edges, enriched with time-based properties and versioning. This approach fits perfectly with real-world scenarios where connections are always changing, making data management more natural and efficient.